Hello everyone! This video would focus on conic section, specifically on parabola with vertex at HK. And this is the fourth part. In this part, we're supposed to determine the equation of the parabola given the coordinates of the vertex and the equation of the directrix. Before we jump into this example right here, let's go over the basics of the parabola with vertex at HK. We remember that there are 4 cases of a parabola with vertex at HK. But before we dive into these 4 cases, let's have the parts of every parabola. The first part that we need to remember is the vertex. So this is located right here. So this is our vertex, and this is actually represented at HK, coordinate HK. Another part that we have is the focus. So this is our focus right here. Now we remember that the location of the focus from the vertex determines where the parabola opens. If the focus is located to the right of the vertex, that means that the parabola will open to the right. On the other hand, if the focus is to the left of the vertex, then the parabola opens to the left. We also remember that the distance from the focus to the vertex is represented as P. And this is also P right here. Another part is the ends of the latus rectum. So these 2 points that we have here are the 2 ends of the latus rectum. We need these 2 ends in order that we can graph the parabola from the vertex. Okay, now we remember that the distance from the focus to one end of the latus rectum is 2p. So I'm going to go ahead and write that up here. We also remember that this value of p here, which is from the vertex to the focus, this value right here will be negative. The reason for that is because it's going to the left. While on the other one right here, the value of the p is positive because it's going to the right. Now, another part that we need to remember is the directrix. So this is the directrix right here, represented in a broken line. Now, we also remember that the distance of the directrix from the vertex is also P. So I can go ahead and label that up here. This tells us that the vertex is actually in the middle between the point where the directrix passed through and the focus. So the vertex is in the middle of these 2 points. Another part of the parabola is the line of symmetry. The line of symmetry will always pass through the focus and the vertex. So this is our line of symmetry. On the right, you will see the first case. I labeled it as case 1, and that is when the parabola opens right. And well, case 2 is whenever the parabola opens to the left. For these 2 cases, the equation that we are going to use every time will be quantity y minus k squared equals 4p quantity x minus h. So this is the equation that would work for these 2 cases. We remember that the sign of the p matters between these 2 graphs. Whenever the p is positive, it opens to the right. Well, if the p is negative, it will open to the left. So they're pretty much the same thing, but the p matters because it determines where the parabola opens. Now let's have the third and the fourth case. The parts of the third and the fourth case are pretty much the same thing. We have the vertex. We also have the focus. Now, looking at this for case 3, since we again remember that a parabola opens towards where the focus is from the vertex. Since from here, our focus is located above the vertex, then the parabola opens up. In this case right here, since our focus is below the vertex, then that means that the parabola will open down. Again, we remember that the distance from the vertex to the focus is represented as P, And so from here, we can go ahead and say that the p-value here is positive because it's above the vertex, while the p here is negative because it's below the vertex. Now, the other parts would be the ends of the latus rectum. So we're going to need these 2 points together with a vertex so that we can sketch the parabola. Now, we remember that the distance from the focus to the end of the latus rectum is 2p, and this is also 2p. The same thing for this one right here. This is 2p and 2p. Another part is the directrix. We remember that the directrix is always located opposite to the focus from the vertex. So it's going to be opposite to the focus from the vertex. And then we also have another part here is the line of symmetry. So the line of symmetry is a line that passes through the focus and the vertex. For cases numbers 3 and 4, the general equation of the parabola would be quantity x minus h squared equals 4p y minus k. This is the formula that would work for these 2 cases. Case number 3, when the parabola opens up, and case number 4, when the parabola opens down. We remember that if the p is positive, then it opens up. And when the p is negative, then the parabola opens down. Okay, going back to the problem right here, determine the equation of a parabola with vertex at 5, 0 and with directrix x equals 9 and sketch the graph. So looking at this equation, we're supposed to plot the vertex. Again, the vertex is at 5, 0. So the x is 5, the y is 0. So this is our vertex. And it's also given that the directrix is x equals 9. So on the x-axis, we go to 9 and we draw the directrix. We remember that the focus of every parabola is p units from the vertex. So I'm going to write the statement up here. We remember that the distance from the vertex to the directrix is the same distance from the vertex to the focus. So then if we look at this value right here, that's going to be 1, 2, 3, 4. So I go the opposite side, 1, 2, 3, 4. And this is where our focus is going to sit. So I'm going to label this as F. This tells us that our P value is 4. However, we are taking a negative value. The reason for that is our focus is to the left of the vertex. So I will put negative here and label this. Since our focus is to the left of the vertex, we can go ahead and say that this parabola is going to open to the left. So I'm going to write that down here. Since this opens to the left, we can go ahead and say that this is an example of case number 2. By the way, I can go ahead and write the coordinate of the focus up here. So our focus is at 1, 0. So we go ahead and write the equation for case number 2 down here. Please remember that our h and k would be the coordinate of the vertex. So this one right here is our h, and this one right here is our k, and we got a value for p. So we plug it in here. So this is how it's going to look like. So y minus our k is 0. So I'm going to write 0 right here. And then that is squared equals 4 times the value of p, again, is negative 4. And then that is x minus our h is 5. So I'm going to write 5 right here. So our equation would come out y. We don't have to write the 0. So it's just y squared equals negative 16 x minus 5. We can simplify this as y squared equals negative 16 x minus 5. So this is the equation of this problem that we have up there. Now we are going to sketch the graph. Before we can do that, we are supposed to determine the ends of the latus rectum so that we can connect the vertex to that first end and the vertex to that other end. Now we remember that one end of the latus rectum has a distance of 2p from the focus. So I can go ahead and show the work up here. So this means that I go up 8 and go down 8 to get the coordinate of the ends of the latus rectum. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So it's going to sit here and then down 8 as well on the other side. So this is where it's going to sit. So then the coordinates of ends of the latus rectum would be 1, 8 and 1, -8. So these are the coordinates of the ends of the latus rectum. So that from here, we can go ahead and sketch the graph of this parabola. So this is the equation of this word problem right here, and this is the graph of this equation that we have right here. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. We're supposed to determine the equation of the parabola with vertex at -1, -4, and a directrix of y equals -7. So the vertex is located again on -1 and -4. So I'm going to label this as our V. And the directrix is located at y -7. So on the y-axis, I go down to -7 and sketch the directrix. Now we remember that the focus is p units from the vertex. I'm going to write that statement up here. Now we remember that the distance from the vertex to the directrix is the same distance from the vertex to the focus. They're just on the opposite side from the vertex. So from here, we can go ahead and say that our directrix is located 1, 2, 3 units down. So I go 3 units up. 1, 2, 3. So this is where our focus is located. We can go ahead and say that the coordinate of the focus then is -1, 1. So I'm going to write that up here. So -1, 1. Now we remember that the distance from the vertex to the focus is represented as letter P, so that we can go ahead and count it. 1, 2, 3. So that's gonna be 3, and I take a positive value. The reason why this is positive because it is above the vertex, or the focus is above the vertex. So I'm gonna write that down here. Looking at this problem right here, we can tell that our parabola opens upward, because remember, the parabola opens towards where the focus is. So this is going to open upward. So then this is an example of case number 3. So I'm going to write that up here. Okay, now the general equation for case number 3 is... Okay, now what we do is we plug the values of h and k. Now remember, h and k is the vertex. This represents our h, this represents our k, and I will plug the value of p into here. And so our equation would come out. So this is the equation of this word problem that we have up there. Now, our next task is to determine the two ends of the latus rectum, left and right from the focus, so that we can sketch the graph. We remember that one end of the latus rectum is located at a distance of 2p from the focus. So I go ahead and show the work up here. So the value is 6. That means we go 6 spaces to the left and 6 spaces to the right. And then we determine the ends of the latus rectum. Okay, so that from here we can go ahead and sketch the graph. So this is the graph of this problem that we have right here, and this is the equation of this graph and this problem that we got up there. Now we remember that the line of symmetry is the line that connects the focus and the vertex. So I'm gonna go ahead and sketch the line of symmetry up here. Did you get the same answers as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!